Let's talk about psychrometrics. So what you see in front of you is a typical water cycle. Starts with evaporation, goes to condensation, then it rains down, precipitation, and then collects, and then starts back over with evaporation. So what does the water cycle have to do with psychrometrics? Well, psychrometrics is a science of measuring water vapor in air, and we use that a lot in MEP. This is a psychrometric chart, one of the tools we use in HVAC. So today we'll be discussing how to use it and what it is and how to read it. So let's start with dry bulb. Dry bulb is your line up and down, your vertical line. This example uses 70 degrees. This is a wet bulb, it's diagonal. So this one is showing 60 degrees. Dew point, this one is showing it at 50 degrees. And dew point is basically your water level, how much water you have in the air. So that's an important piece of information that everyone needs to remember. This is relative humidity. It's a curved line. The one thing about relative humidity is it changes with temperature. So the warmer it gets, the lower the relative humidity is going to get. If you keep everything the same, meaning your dew point stays the same, your water level is the same. So when you turn the temperature down, the relative humidity does go up. Enthalpy is used for calculating energy content in the air, specific volume for your densities, and your saturation point. That's basically where air is 100% saturated, 100% relative humidity, and it starts condensing. And then you have humidity ratio, which is grains of moisture per pound of dry air. So example number 1, we'll be looking at a cup of water. The cup of water on the left is a larger cup of water, so let's say that's 72 degrees. It's about 60% full. So when we start pouring it into a smaller cup, let's pretend the smaller cup's 53 degrees. The smaller cup's basically 100% full. So it's the same content of water, but again, it's an example of relative humidity. Let's move on to example number 2. Example number 2, let's pretend we're designing a clean room and we're given conditions of 64 degrees Fahrenheit, and they want it to be between 30 and 50% relative humidity. So you have your vertical line and then you have your 2 curved lines. The one thing to note is your 50% relative humidity, that's your upper end. You'll more than likely see that during the summer, and then your low end would be in your winter conditions. So you dehumidify down to 50% relative, and you humidify to your 30% number. So again, your dew point is shown here, 45 degree dew point at 50% relative. One thing to note, if you're selecting equipment for your dew point calculations, you need to remember that you have internal latent gain and vapor transmission. I typically use about 2 degrees. So in this case, when we want to dehumidify, I would like to supply a 43 degree dew point, so you have about 2 degrees of latent gain. For your winter condition, you basically have 35 degree dew point, so you'll probably be at 33, and then you want to humidify a little more for your latent transmission to other spaces that are not humidified. Thanks for watching. Let's talk MEP and check out our other videos.